Have you ever wondered how you get from raw photoresist PCB material and a design to a board ready for soldering? I will show you in this video how I do it currently. Yeah, I'm still working on the process, trying to improve it, and it's certainly not perfect, as you will see. But anyway, enjoy. Okay, so first I print out my layout on transparencies twice. Yeah, and I print it in a way that the toner is actually on the side that will be put on the photoresist PCB material. Okay, so no mirroring when printing that out. Then I'll spray the whole stuff with some density spray. And yeah, I'm using this density spray LFA from Huber. I don't know if that's internationally available. And I let that dry now. Next, I'll cut them both to size. Yeah, these are 2 at once, and I leave a margin of about 2.5 centimeters, or yeah, let's say 1 inch around the layout. That's enough. So, and yeah, one of them is finished, and the other I cut down the margin even further, let's say to 1/2 inch, yeah, 1.5, 1.25 centimeter, something like that. Next, I align the smaller piece of transparency on the larger piece of transparency. And please note, because this is not printed mirrored, yeah, the toner is on this side, and any, yeah, can you see that? Probably a little bit out of focus. Any text is mirrored. So yeah, the text, if you look at it when you put it together, should be mirrored. That's a clean sign, clear sign that you're doing it right. If you can read the text, actually, something went wrong. And yeah, I align it and I fix it with some Scotch tape, of course. So the goal here is basically to stack 2 layers of laser toner on the transparencies, because yeah, at least for my laser, 1 layer is not enough to keep the UV light from reaching the photoresist on the PCB. Then it's usually time to cut some PCB material, and I'm using photoresist original Unmarked. Yeah, it's still good for consumption. And yeah, I've just put the required measurement, the required dimension on my caliper, give it maybe a few tenths more just to be on the safe side, and then I align my fans on the table saw. And I'm using a diamond blade because any other blade will get dull quite fast with that glass fiber reinforced FR4 material, and that's too tight. And I use the lowest possible rotation speed. Oh yeah, and if you're health conscious, you should wear, I have here a FFP2 mask, just to be on the safe side. Okay, the other dimension is a little bit more complicated. That board is now, yeah, the stock 149.5 millimeters wide, but I need a 130 millimeter wide board, so I have to take off 19.5 millimeters. So yeah, I set my calipers to 19 millimeters. Yeah, give me half a millimeter breathing room, 5/10. And then I, yeah, get the caliper here set on the blade and try to align the fan so it's just touching. Yeah, this can be a little bit fiddly, but you do want your dimension right and not to take off too much of the board. That would be, well, most annoying, because then you start from scratch and you wasted board material. Yeah, and then I peel off the protective layer on the photoresist and place it on my exposure mask. And yeah, in my layouts I usually have some crosshairs at the corner to, yeah, help me align the board. And the smaller exposure mask part is on top, and again the toner is on top. Yeah, and when I'm happy, I just fix the board on the exposure mask again with some Scotch tape. Yeah, I know it's a needlessly tedious process, but it's my way. Okay. Now, just for kicks, if you look at it from the other side, and I can have a focus, any writing is now, you can read it now. It's no longer mirrored. Okay, exposing. So for this specific bungered material, I'm using an exposure time of 4:45 on my self-built UV exposure unit. Yeah, card link to the project playlist of that little thingy. Your mileage, yeah, depending on what UV exposure unit you are using, might vary. So we just put the board in and yeah, let it, you can't see it, operate for 4 minutes, 45 seconds. I'm having a coffee now. And it's done. Yeah, I'm careful not to touch the exposed side. And just as a matter of course, I'm storing that in between face down, so no light can get to the photoresist layer. To develop the photoresist, I use caustic soda. And yeah, if you're working with caustic soda, you don't really need gloves, but you should wear protective glasses because it's not good for the eyes. If you get it on the skin, these low concentrations we're using here, it starts to feel soapy, and then you know it's time to rinse your fingers off with water or something. Anyway, I'm using for that specific board material from Bungered 12 grams per liter, and I normally prepare half a liter. So yeah, that is 6 grams I need. And yeah, for other bulk material, 10 grams per liter are sufficient. But as I said, especially for this bungered stuff I'm using here in that project, I need 12 grams per liter. And yeah, you really have to be careful, and that's why I, use a large plastic bathroom bin, whatever, here, because often little tiny crystals of that caustic soda are, flying around. They are really funny guys. Yeah, and there's one here that simply doesn't want to go. Well, I rinse it out with water. Perfect. Let me set up the camera for etching. Okay, the big moment. Let's etch. And we can actually watch that in real time unfold, I guess, I hope. As I said, it's not really hard on your fingers. And the etching solution should be at about between 20 and 25 degrees. And yeah, if I start the timer, we should see something after, well, 10 to 20 seconds. You see first structures. Nice. And usually I'm finished after, with other bulk materials after 2 minutes. 2 minutes 30. But for this special bungered stuff, I'm etching. Oh yeah, you already see it. I don't know if the other camera is picking that up too. What was I saying? Yeah, 2 minutes 30, 3 minutes. Yeah. Just shake. And you can really see how that photoresist is coming off where it was exposed to the UV light. Sometimes I forcefully move the board and you see how that's bringing off photoresist too. But that's really a special thing with that material. I had other bungered materials where the photoresist came off with, just shaking and then rinse it in water and you're done. So we're at the 2 minute mark. And here comes another special step that might or might not be necessary for the photoresist material you have at the 230 mark. And that is, I go over the whole thing with a very soft brush to remove any photoresist that is still clinging somehow to the copper. And I do that until we reach finally the 3 minute mark. And the timing is not that critical. You don't have to get it on the second, and then I'll just put that over into clear water for rinsing. And you won't get a real good close-up of that, but yeah. Just rinse a little. Yeah. Clean my brush. Go over it very lightly. I'm not exerting a lot of pressure. I already exerted too much pressure, and now I think, I'm not sure. I would have to check if this is still usable or if I fuck it up now. Yeah, let's try that. And am I in focus? Not really. Who cares? Yeah, I should be in focus. No, I killed it. Ah, fuck. Yeah. Shit happens when you are demonstrating. So, once again, from the beginning. Okay, second try. I exposed it this time only for 4 minutes 20 seconds, and I have to say I'm a little bit disappointed in that bungered material that comes in a 150 by 300 millimeter also format, because it's not really consistent. That is, the photoresist is not really consistent. And I will now, develop also for a shorter period of time. Let's say only 2 minutes 45, and I will be a little bit more careful with the brush. Let's see, the structures are already showing, very nice. But that worked before, as advertised. The photoresist, where it has been exposed, is coming off. Not really evenly so. But we have still a good minute to go, or something like that. Yeah, it looks good. It looks good. I think I will start brushing it off at 2 minutes. Or maybe 2 minutes 15. Or now. And really just giving it light strokes. And it's not really working perfectly. So maybe I need a third try. Let's give it some time. We will see when we are etching. If this, yeah, it's coming off now. I have to say, I'm not really happy. Not at all. I'm not really touching it, just, you know, creating some current over it. Yeah, but drilling that will be a pain in the behind. Yeah, anyway, we let that dry, and then we etch it, and we'll see how it looks. Yeah, that bungered material, it's not good. For etching, I use sodium persulfate, 220 grams per liter. And yeah, I don't have to prepare it because I still have some solution left. That is actually reusable until it stops etching. And you will know that the solution is used up because the etching will take longer and longer and longer. Anyway, let's put that in and heat that up. And if you store that, you need a little hole in the cap because this stuff produces gas. And if you, well, have a gas-tight container, you run the risk that your container explodes. Okay, another thing about the natrium persulfate is it needs to be at temperature between, ideally not above 43 degrees, but I try to keep it because I only have a manually controlled water bath here, where I have to simply switch the heating on or off by hand. So I try to keep the temperature between 40 and 45 degrees. So my etching solution has reached 40 degrees and it's time to put the board in. And this will take about, with a fresh etching solution, 30 minutes. If it's already a little bit used, well, longer. And if the photoresist really came off, you will see that the copper will change color very quickly. Just rocking it gently. And you see there are little bubbles forming. That means the solution is working. And sometimes I just, you know, move the board a little harder back and forth to get rid of the bubbles, because where the bubbles is, no etching will occur. You see the copper that is no longer covered by photoresist is now really whitish, a white color. And yeah, I will look at it and rock it a little bit, but we are just at 4 minutes now, so yeah, as said, this can take a while. At least half an hour. And sometimes I take it complete off the bath to let the water run off and get rid of the bubbles. But you see, it's not really bubbles, the black spots. That's probably remaining photoresist. Oh, we will see how this works out. Or is it? I'm not sure, to be honest. This might be the first area for the copper to go. Oh yeah, this is developing fast. Etching fast, that is. Yeah, and when I take it out, I try not to grab the areas where there should be copper. But yeah, you can see how the copper is going very fast now. And I'm using that etching solution a second time. So yeah, it's still going very strong. Yeah, I suspect that spot that is still there, that there was still some photoresist. But yeah, well. On the minute, 30 minutes, or on the second 30 minutes, and we're done. Well, actually a little bit early. Yeah, I can't see any copper there anymore. So let's get that over into the clear water. And rinse. And we're done. Almost, with the wet work. Well, I have a closer look at that in a second. First, I will expose it again in the UV exposure unit, and I won't show you that because I already saw that and it's boring. And then it will go again into the bath with the caustic soda to get the photoresist of the copper. There are other methods for that, like using some solvent or so, but yeah, well, you already have that on the ready, and so why not use it? So give me a sec to expose that again. Yeah, I exposed this board aggressively, 5 minutes. This second exposure and developing stuff is really just to get the photoresist of the places where it protected the copper, so it's no longer on the copper. And as I said, you can do this with a solvent, but since we have the developing solution already here, just expose it a second time and yeah, put it into the solution for 3 minutes and you're done. You can already see the stuff coming off, and you see how the copper really starts to shine where the stuff is completely off. Now after 2 minutes, yeah, you see it in the water. Now it's coming off hard. I think it's all off now. Perfect. One last rinse and we are done with the wet work. Okay, we'll have a closer look after I dried it, but yeah, it came out acceptable. Not acceptable good, but acceptable. I see some flaws. The board turned out better than I expected, so all the fine structures survived, yeah. The edges of all the traces are very nice and clear. Yeah, there is no under etching or over etching. The text is clearly readable and of course no longer mirrored. Yeah, there's some nastiness here and some details, but that's okay. The only imperfections, and that's not an imperfection, this was actually in the exposure mask. I need to drill 2 holes here. Yeah, the only imperfections are that there is some copper left at a few spots where it should have been gone. But these are, little holes in the exposure mask where UV light came through. So, yeah, I'm quite happy with that result. Let's have a look at the result of the first exposure and development that completely failed. You can see these discolorations here all over the place. That is where the photoresist didn't come off completely. And in other areas, like here in the text, you see the photoresist came off in areas where it shouldn't have. So yeah, trying to etch that would only end up in catastrophe. It would take ages to get the copper off the areas where there's still a thin layer of photoresist on, and by the time the copper is gone here, all your traces and finer details would have been under-etched and would have been gone. So yeah, forget about that one. But I wanted to show it to you just to demonstrate that, yeah, slight changes in the quality of your board material or your chemicals can mess up your established process. When I'm drilling, I find it helpful to have a drill plan besides me. So yeah, the standard hole size is 0.8 millimeters, but there are several other holes with other diameters. I will, in the first pass, drill almost all holes with 0.8 millimeter, even those holes that will get bigger in the end. With the exception maybe of the isolation slots I need, because yeah, this is you need a little special technique there, but I'll show you. And I do use diamond coated drills because, again, yeah, glass fiber reinforced, and yeah, your usual drills will get dull quite quickly. So, and I guess these were all the holes, but for the isolation slots I need in 8 millimeter. And now for the 1 millimeter holes, and yeah, this is much easier because they are all pre-drilled with 0.8. 1.2 millimeters. 1.5 millimeters, and I will also use that drill to widen the holes that have a target diameter of 3 millimeters, because I don't have 3 millimeter diamond coated drills, and yeah, the 3 millimeter holes will be a bit messy. Before I drill the 3 millimeter holes, yeah, I would have to change the collet for that. I will drill the 1.2 millimeter and 1 millimeter. Where is it? Back here. Oh, probably can't see it. Yeah, you can. Isolation slots. The thing is here for the 1.2 millimeter isolation slots, I have here a drill marking in copper every 1.2 millimeter, but I will in the first go only drill every second one, and then in the second go I will drill the ones in between, and then I will use that diamond coated drill to basically mill the slot out, hopefully. And yeah, maybe you can, oh, where is it? Down here. Yeah, it's almost, yeah, through. I just really have to, yeah, do a little bit of milling. And, oops, there you have your isolation slot. Okay. Perfect. Yeah, 1 millimeter isolation slots. Yeah, up here. That's really fine work. Okay, and these 1 millimeter slots, they are really harder to do because that smaller diameter, it's only 0.2 millimeters, but it deflects a lot more than the 1.2 millimeter drill, and that makes drilling and milling these slots a little harder. Yeah, I just noticed I forgot an isolation slot, and I will have to do that freehand, which I'm not looking forward to. But I will do it in 1.2 millimeters. Yeah, basically this is a mounting point for a heat sink, and the heat sink will be on the potential of that trace here, so live or neutral. And yeah, that trace here is neutral or live, depending on which way you plug in the thing, at least here in Europe. So yeah, a little separation there is not too bad. And now for the dreaded 3 millimeters holes, 6 of them. And now I have a little problem because I forgot to put here some markings in copper for drilling, because around the heat sink, can we get the paper in here? Probably. Now a whole bunch of, I think, 2.5 millimeter holes, so you get some airflow. Yeah, let me think about that for a second. To locate the missing holes here I need for ventilation into my heatsink, I printed out a paper template from my layout, and I located that at 4 holes that are already in the board. And now I can remove the drills and do some more holes. First with 1.5 millimeters, then with 2.5 millimeters. Yeah, I just learned that I don't have a collet for 2.5 millimeters, so slight change of plan. I go for 2.35 millimeters. After all that drilling, I cleaned off the board with some alcohol, and I also scratched off these little specks of copper that were still left at 3-4 places. And now the last thing is, oh, it's only in German and French, but it's contact SK10. Don't I have it in Great Britain English? No. But basically it's a sprayable flux which at the same time protects your copper traces from oxidation. Let's try that and focus down here. Now I let it dry, and then we have a look at the final product. And here we have the final result, and it turned out, well, okay. A fully featured single-sided board with, traces of course, ground planes, pads, isolation slots, mounting holes for the board itself, and a heat sink, ventilation holes for air convection through the heat sink. Everything you will ever need in a single-sided board. So we went from raw photoresist PCB material and the design to the final product in, well, a little under 2 hours. Not too bad, huh? Bye.